Greetings to Encik Afiat and my fellow friends. Today I'm going to present about my task 3 of mathematical reasoning project report. So for the introduction, I would like to explain what is the non-routine problem and the Polya problem-solving process. So let's start with the non-routine problem. A non-routine problem is a maths problem that cannot be solved by simply applying a memorized formula or a standard procedure. It requires us to think and reasoning to solve the problems and find out the problem solving strategies such as working backwards, drawing a diagram, looking for patterns, making a table, use algebra expression, guess and check, or even solving a simpler problem first. Next is the Polya problem-solving process. This process is one of the most famous and practical methods for mathematical problems, especially for non-routine problems. And this process is developed by a mathematician and educator named George Polya. His 4 steps of Polya thinking process help students to think logically, plan carefully, and check their work effectively. So the first step of Polya problem-solving process is to understand the problem, which this step emphasizes the importance of ensuring you thoroughly comprehend the problem. In this step, students learn to read and analyze the problem statement, identify the key information, and clarify uncertain information. This process encourages students' critical thinking as students can develop the ability to break down complex problems into smaller parts. So the second step is to devise a plan. In this step, students could explore different strategies and select the most appropriate approach or methods. Students can brainstorm the possible solutions such as draw diagrams, make tables, or create other algorithms which helps to foster their creativity and diverse thinking. The next step is to carry out the plan. This step helps in implementing the chosen strategy by carefully applying the steps of the plan in a systematical way. So it is important to be thorough and patient to ensure that the calculation and the reasoning steps is completed accurate. So the last step of the Polya solving process is to look back. After finding a solution, we should review our results to confirm they make sense and the problem is completely solved. We can generalize the solution by considering how the same strategy might apply to other similar problems in the future. So this is the non-routine problem that are made by our group. The problem is a rectangular school garden measures 10 meters long and 8 meters wide. The gardener plans to build a uniform shaded path of width all around the inside of the garden. The remaining inner rectangle will be used for planting flowers. If the area of the shaded path is 24 square meters, find the width of the path. So this is the diagram given by us. So for the next solution, which I've done individually, I use the working backward method to solve this problem. This method is particularly useful method in situations when the end result of a problem is known and one has to find the initial quantity. So the key principle of working backwards are starting from the solution, step-by-step reverse, and logical reasoning in reverse. This method helps us to enhance our critical thinking skills, encourage goals-oriented problem solving, and it is useful in algebra, geometry, and numerical problems. So first step is to understand the problem. Here we know that we have the rectangular garden measuring 10 meters by 8 meters. Beside it, there is a uniform path of width x all around the edges, and the area of the path is 24 meters squared. So we are asked to find the width x of the path. Thus, we know that the total garden area is 80 meters squared, which is 10 multiplied by 8. And the inner flower area is the area of garden minus by area of path, which is the 80 minus 24 equals to 56 meters squared. Next, let us devise the plan. So the problem gives us the result of the area of path, which is 24 meters squared. So working backwards means we should start from last. So we have the remaining flower area is 56 meters squared, and we should determine what the earlier situation could have produced that result, which is the inner dimension after subtracting on all sides. So the third step is to carry out the plan. So we have the inner rectangle, which is the flower bed, have the length by 10 minus 2x and the width equals to 8 minus 2x. So we know that the area is 56 meters squared. So we can assume that 10 minus 2x multiplied by 8 minus 2x equals to 56. And then after expand it, we will get a quadratic equation, which is 4x squared minus 36x plus 24 equals to 0. After simplifying the equation by dividing by 4, we'll get x squared minus 9x plus 6 equals to 0. And then we know that the number is not a whole number after we factorize it. So we use the formula method. So by substituting a equals to 1, b equals to negative 9, and c equals to 6 into the formula, we'll get x equals to 0.725 meter or 8.275 meter. So since the path must be fit inside the garden, so we'll reject 8.275 meter because x must be smaller than 8. Thus, the x equals to 0.73 meters. So the last step is to look back. We'll check if x equals to 0.773 gives the correct areas of path. So we substitute the 0.73 inside the equation and we'll get 8.54 multiplied by 6.54 and we'll get 55.9 meters squared, and we round it and will become 56 meters squared. So the shaded area is the whole area minus the small area. So we'll get 80 minus 56 equals to 24, which match the given information. Therefore, we can confirm that the width of the path is about 0.73 meters. So in conclusion, these tasks demonstrate how non-routine mathematical problems can be effectively solved through systematic reasoning and the application of Polya problem-solving process. We know that the Polya solving process is very useful. By engaging in both group and individual, we learn that problem solving in mathematics is not just applying formulas, but also understanding concepts, analyzing relationships, and selecting suitable strategies. Through the group's algebraic method, we practice translating real-world situations into mathematical equations and solving them logically. Meanwhile, the individual working backwards method approach emphasizes critical thinking and reverse reasoning to reach the correct result. Both solutions leads to the same answer, which provide the consistency of the method used. The consistency and the accuracy of the method used. The problem-solving process encourages accuracy, reflection, and logical organization in our work. Moreover, This activity enhances our collaboration, communication, and mathematical reasoning skills. So in a nutshell, this non-routine problem strengthens our confidence in solving complex mathematical tasks by combining creativity, logic, and structured problem-solving strategies, illustrating the practical power of Polya models in real-life mathematical applications. And that's all from me. Thank you for listening.